education. And you can learn more about our work by visiting our website at aimcenter.org. Along the way today, we invite you to correspond with us, communicate with us in the chat. Make sure you have all panelists as your selection there and attendees so that everyone can be able to share with you in communication or sharing ideas or how you're, maybe questions you might have. There is also a Q&A feature, so you're free to use that as well to share your questions and your progress. So we're here today and we're going to engage in what we're calling a pull-up polyhedra. We're making a specific polyhedra, and we'll get more into that in just a bit. But Beverly is going to share a bit about the STEAM content around our activity and get us started with an introduction.
Well, hi, everyone. I am so excited to be here. So a pull-up polyhedra, I mean, we don't normally use the word polyhedra very often, but it's just really simply a polygon, a three-dimensional polygon with faces that are all polygons. So we often see a cube, and the math term for that would be a polyhedra. So when I was thinking about a pull-up polyhedra, it got me starting to think about, like, where do we see things that move from flat, which is what our polyhedra will start as, into something three-dimensional. So I brought some things to show you. One of the first things we think about is a cereal box. Now, I don't know if you are a recycler, but I am, and I can't tell you how many times I've pulled the bottom of this and just kind of flattened it, and that was it. And then I put it into the recycling because I needed it flat, but I never really thought about what that shape was. So I started opening boxes and asking questions, and I started realizing that they all have this spot where they had to glue it. And then I went on YouTube and I started looking at how boxes were made, and I could not believe how much effort it goes into to make a simple box. So now we open it up and it's going to look very similar to our pull-up polyhedra, but that's not where it ends. So I was getting some fast food with my kids and I noticed this drink container that has to pop open. And I thought, there are times where we want something to change shape. And then we started thinking about umbrellas, but it's not even just for function. So here would be one of my last examples of something that I saw was this light bulb that we just got. We were doing some remodeling. Now this is a very large light bulb, and they actually used a net, and a net is kind of just what happens when you open up a polyhedra and it's flat, it's in a plane. They used it to protect the light bulb. And so here's all this cardboard. Now I wonder if we showed this to kids and we said, what do you think this will make? I mean, I know I probably wouldn't have guessed a carrying case for a light bulb, but that's just kind of the beginning. And one of the things that made me so excited about this was once you start looking, you see all sorts of places where things move from that 2-dimension to 3-dimension. And there's just so much engineering that even goes into simple things like a box. And that's kind of what we're making today, is a box, something that's flat, that starts flat and becomes a box.
That's great. I think you gave a lot of great examples. Maybe some of you are already looking around your area or thinking of encounters you have with boxes, things that hold other objects that have a function. And when we start looking at the engineering piece, whether that's taking something apart or building something for a specific problem or task that we're trying to do, we start thinking about all the details. And Beverly started mentioning some of those today, and the vocabulary that's around it, that's really heavily mathematical that maybe we don't necessarily use. So box or a carrying case or things like that are probably how we describe a lot of these things. But it's always good to start introducing a really academic vocabulary so that we can be specific about what we're talking about. So sometimes we see shapes and we see them as just flat. So if you have a piece of paper and you cut it into a shape, it just has a 2-dimension, a length and a width. But what we're going to investigate a little bit closer today is how things are a little bit more 3-dimensional. And we really do live in like this 3-dimensional world where we're looking at really 2 dimension as kind of the odd thing, but 3 dimension is kind of where we're living, that space that we're living in. So the vocabulary is not only mathematical, but it's in our English language, how we change words when it goes to a plural. So if we're talking about one object that has many faces instead of sides, we're saying faces, then we're talking about a polyhedron. A polyhedron is just one object that has many faces. But when we're talking about more than one, then we have polyhedra. So we have more than one of those things that have many faces, and we have more than one. Today, we're going to specifically do one of those polyhedron, and we're going to go a little bit more deeper into just that one. But I think it's important for us to just kind of lay the foundation. As we start using this vocabulary, we'll point out what we're talking about and how they're related. So you can see the mathematical categorizations or classifications, but also our English language, how we go from one to the other.
Right.
So what's next? Are we going to?
I forgot one of the other examples that I found was the solar sail.
Oh, yes.
And so we're going to put a picture up on the screen. And the solar sail, that you don't really get the dimensions of that. But if you look and you notice that it's actually like 12 inches by 4 inches, which is kind of like a shoebox. But that solar sail is as big as a boxing ring. That's the best kind of thing that maybe people have seen before to see how big that is. So all of that foil, which is really thin, has to fit inside like a shoebox and gently come out in outer space in order to be able to then sail. And what it's sailing, and it's gathering information and data for science. So there's just so many different places where some of this is going to come into application. But then one thing else also I wanted to kind of highlight is, so we're doing some STEM focusing, and we're actually doing a little STEAM today because we're going to have some fun with art. Today, I kind of want to just highlight technology and engineering. And one of the things that we often think of engineering is like, that's the job, engineer. But engineering is really more about design. So if you've ever decorated your room, it's kind of like you've engineered a space. And so when we're talking about it in STEM or STEAM, we're using that broader definition of that engineering, that design idea. And so today we're going to do some designing because we're going to have to choose where we're going to put holes for our pull-up polyhedra. The other one that I kind of wanted to highlight was technology. Technology isn't just your screens or a device or electronic. Technology really has to do with tools. And the tools we're using today is string and scissors and hole punches possibly, or maybe you won't have a hole punch and you'll get creative with that. So I wanted to kind of highlight those because I think this activity actually highlights some not as common ways that we can do both technology and engineering. And then some NGSS practice standards that we're going to be looking at today is developing and using a model. So we're building this model of this polyhedron, and then we're also asking questions, defining problems, planning and carrying out investigations, because there's going to come a point where we're going to have to kind of figure out where we want to put the holes so that our polyhedron can come up the way we want it to. So there isn't just one right answer. So that's just kind of some of the NGSS that's happening and some of the STEAM that's happening today.
We also wanted to highlight spatial reasoning because this is one thing that we've gone through in some of our hands online is really highlighting, well, what is spatial reasoning? How is it connected to the things that we learn in school, but also the things that we just learn as we develop and as a child. So spatial reasoning here, it is about the location. It is about also how I move my body through the space that I live in, but how I move objects through the space. So it is something that children develop. There are children that intrinsically have some of this when they're growing up, that they do maybe a lot of spatial activities or have a lot of spatial experiences, this could be very strong in a young child. And so it's very important. It's one of the most important skills that we're noticing in research around the STEM profession. So it's really important to not only talk about these kinds of things where you're talking about in words and vocabulary like next to, on top of, side, between, but also for children to have experiences, because although you might have experiences that allow you to have a little bit more stronger spatial skills, all of us can get better at spatial skills. And it's so when we're having these experiences where we're seeing two-dimensional things become three-dimensional objects, children can experience the vocabulary around it, but also the hands-on piece about it, about learning through the experience and highlighting those discussions that we always try to encourage with questions and curiosity prompts. So we'll definitely see spatial come out through this activity as well.
Yeah. All right, so I think we're going to get started, and Aileen is going to kind of go through some of the material list, and I am going to get ready with my camera so you can see my hands.
Yes, so we're going to go through the material list. We always try to have materials that are very common. So I'll go through this list, but also tell you about any substitutions that you can have. If you weren't prepared, you can think about other things that you can use as alternatives. So we want some sheets of paper. It only takes one to make a model, but just get some extra just in case. We're always prepared that if we make mistakes, it's okay. It's a first iteration of you as an engineer. And as you do your second iteration, you learn from those mistakes. So have that as a preparation, especially if you're building along with a little one today. So a single hole punch, if you have one, that makes it a little bit easier to make those holes where you'll thread through the string or the yarn. So if you don't have one, I've used just putting the paper over something that has a little bit more of a sponge. So if you have carpet or a blanket, you can put that over and then use something sharp to make those holes. That also works through threading through. Some string or some yarn works. I imagine maybe even dental floss would work. So anything in that kind of category will work. Some tape or some adhesive. So that could also be a glue or a glue stick that will work for today's activity. Pencil, recycled cardboard. So the actual model isn't made out of the cardboard, but it's a nice little base. So in the video you're watching, there's a orange cardboard that it's sitting on. It helps it to have a little bit more of a stability and gives it a foundation. And then like Bev mentioned today, we're going to integrate some art. So if you have any art supplies around, crayons, markers, stickers, anything you like to decorate with today, grab some of those things as well. So Bev's, I think, is ready, and we're going to start making. So I hope you'll make along with us. If you need us to slow down, or if you have a question about something in the steps that you've missed, just let us know in the chat, and I'll be sure to have Bev pause and redo things. This is an interactive time for us together, so please communicate with us as appropriate. All right, Bev, how do we get started?
All right, so the first thing that we're going to do is we need to make our paper, which is probably an 8 by 10 paper, into a square. Okay, so we do need a square. So there's a few ways you can do that. You can use a ruler if you have a ruler, or a simple way, and just in case you don't have a ruler, is if you take the edge and you fold it diagonally. And the reason I have this under here is so that you can kind of see that a little bit better. So this is my square. So just think about it. This is a side right here. And we're taking that side and we're using it to measure how far we want to go. And you can use just a marker if you want to trace along there. And then be able to cut that part off with a scissors. Now today, to make life a little easier for me, I have some papers over here. One of the things that we noticed when we were practicing with this was that it's kind of hard to see some of the fold lines. So, can everybody hear me okay?
Yep, you're coming in great.
Okay, perfect. So now we have a square. So the first thing that we're going to do with this square is we're going to fold it in half like this. Now, when you fold it in half, and here I'm going to grab my new sheet that draws that line a little bit better. When you fold it in half like this, you're going to open it up and you're going to fold each of those halves in half again like this. So that's why I drew this black line right here, so that each one's going to go into that black line, and then we're going to fold this other one into the black line as well. So it almost kind of looks like a book that's opening and closing. So each of these strips is 1/4. Now, one of the things with this, along with origami, if you've ever done it, is you want to fold both ways. So we had folded one way, but now we want to fold the other way as well. We really want, because this fold is going to be like a hinge. Think about a door opening and closing. We want that to happen really easily. So on these two, we need to fold them both ways as well. And then flip it over, fold it the other way. Flip it over and fold it the other way. So with this step, you should have 4 equal pieces. All right, so now we've got one with our 4 equal pieces. Now see how these lines are kind of standing up? Well, we want to turn them so they go landscape. So now it looks like they're going from side to side, because we're going to actually do that same thing again. We're going to fold it in half. And now we'll have 8 pieces. Got my lines on here. So you can see these 8 pieces. But now what we're going to do is we're going to go into the center black line again, folding each of those halves in half again. So some of you may have already guessed what this is going to look like. And don't forget, you want to fold both ways. So we fold one way, we flip it over, we fold the other way. And the reason we're doing that is because when we go to pull up the polyhedron, we want it to kind of come up really nicely. So we want those fold lines to be nice hinges for that. All right, folding both ways on the other side, flip it over, fold it again. All right, so I know it's kind of hard to see. That is what you end up with. So you have got a 4x4 array. That's just a fancy word for like a grid. And you have these squares. Now these squares are there because we are going to cut out some of them. Now I was trying to think, you know, what would be the best way to indicate that? So I'm just putting sticky notes on the ones that I am going to cut off. And I'm going to cut off what looks like a lowercase t. So you can start to see it forming.
And as you're doing that, Bev, I just wanted to emphasize that I like how a lot of what you were introducing was a lot of the math that parents and teachers are trying to emphasize, and whatever's appropriate. So Bev said, you know, the shapes. So if your child that's appropriate, you know, you're emphasizing the shape as you're doing the fold. She also talked about fractions. So that's a great way to emphasize a discussion around fractions. And then at the end, you had an array, and there's some kids that are studying arrays prior to when they go into multiplication. So it's a great example of just that folding technique to get your grid is a great way to have those discussions as you're doing that with a young child, or perhaps you're teaching this virtually over Zoom or something like that, where students are watching you, emphasizing that vocabulary, maybe highlighting those aspects that you're going through in your own content.
Yeah, definitely. There's so many mathematical opportunities. And I think that's something that's so important for teaching and for parents. It's not just one standard or one thing we're doing. They're all over the place. And sometimes we can feed off of kids' curiosities and what they want to do. So now that you see all these blue sticky notes, that's what we're going to cut off. So go ahead and use your scissors and cut it out. And don't worry if you accidentally cut too far. I have an example of one that I actually taped because I was like, I have all these extras that are left over. I don't want to make a whole nother one. I want to just tape one together real fast because I wanted to see if I could get it to pull up. So first we're going to take that one. We'll get rid of that. We don't need that anymore. But like I said, if you want to use those squares, they're all congruent, which is just a fancy math word for just the same. You could make another polyhedra with them. All right. All right, so we've got our letter T. All right, so now that we're done cutting it out, now we're going to talk about putting, we're going to string it. And so what I've decided would probably be the easiest is if I put these little black pieces of tape on each of the vertex that we're going to put a hole punch in. So 1 is a vertex, 2 are vertices. So we're going to start by hole punching down here at the bottom. And remember, Aileen talked about that spatial language. So over here, it's to my right, and it's in the top corner. So top right. And we'll go over here to the left on top.
And just to add some more vocabulary, what Bev has just cut out is a net. And we use the word net in other ways, like fishing net, right? But in mathematics, a net in this case is the two-dimensional shape we cut that will create a three-dimensional object. So just like when Bev at the beginning unfolded the cereal box, she went from the solid, the box, to the net. By folding that out and lying it flat, she had the net of that. So what we've created, that's what we call as a net.
Awesome. Okay, so hopefully this isn't going too slow. I didn't want to rush too much, but now each of these places where I have this black tape, I'm going to do a hole punch. All right, so back up here.
And tape is a great way to reinforce the holes too, because if the holes are too close to the edge of the paper, it's easy for it to rip sometimes by pulling with the yarn.
Yeah, that's a great point, Aileen, because, you know, especially with little guys, they're going to start yanking on it and it might rip, but it's so easy to just add some tape on the corner and poke another hole in. So the tape is, like you said, even stronger. So now that we have all of our holes punched, we're going to start threading. Now, my hole punch is pretty big. My first hole punch wasn't, and I actually used a little bit of tape on the end of my string to help it from fraying. I don't know if you've ever done any actual sewing, but sometimes getting both of those, all of the thread into the hole can be a little bit tricky. Now, this first time we're going to walk you through putting it together, but let me show you kind of what it's going to look like. So here's one that's done. And one of the things that I noticed when I was trying to think of what's the best way to help people kind of put it inside, starting from the inside and then going around the outside here, is really you kind of always do the opposite. So you start, so like right here, let's say we started on the inside and now I'm on the outside. Well, now on my next hole, which is up here, I'm going to start on the outside and I'm going to go to the inside. So it took me quite a few nets of before I realized that that was the pattern. So now I stopped on the inside here and then I'm going to go to the outside. Now you may be wondering, well, why is that, Beverly? Well, think about it. When this hinge is coming together, you want that string to just go right inside there. If not, if it had to go around this, that's part of the engineering that would be a little bit tricky because it could get snagged on the edge there. So we want that to be a real easy transition. So we ended on the outside. We start on the outside, we go to the inside. Now we're showing you one way to do this, but guess what? There's more than one way. All right, we stopped on the inside here And now we'll go to the outside. And then we ended on the outside here. And then we'll go to the outside, back to the inside. All right, so we have threaded it. Now, like I said, here's one that's already done and it's taped to my table. That is why we had you bring this cardboard, because if you tape it onto the cardboard, that just makes it a little bit more stable, especially for a little guy to start pulling it together. So here we go. And now we have our pull-up polyhedra. All right. So does anyone need any steps repeated? So just so that, well, I'll see if Aileen can look in the chat and see if anyone needs anything repeated. So I started trying different ways. And here was my example of, like I said, I just taped it real quick in order to have it start. And I thought, well, could I do this the other way? And so watch this. I thought this was kind of fascinating. It's like the walls come in and pull together. So this was just kind of the first way that we did it as we were just exploring. But I kind of like this where the top of the T is the bottom, because the walls kind of come in first and then the top comes down. And you can see I have a little Lego character here. My youngest was very intrigued at this idea of building a little house and then pulling it together for the figurine.
That is great. We didn't have any questions yet, but we had some people notice that we used one possible net of a cube. So everyone sees now that we made the polyhedron called a cube, which is a little bit more familiar shape. And they were saying in the chat just that there's more varieties of nets for a cube than the one that we're doing today. And they wondered if other ones would work to make a pull-up.
I love that. I love that. So that is a great question. And I have little polyhedras here that I have started to experiment with that on. You can see this one, it's like a capital T instead of a lowercase t. And then we have some others, ideas for you to kind of play for the next couple of minutes. One of them is you can make it into an actual house. Hopefully you saw that here. You can see the door and the windows. Now, my challenge for you is don't make it a house and then put the door and windows on. You need to open it up and try to figure out where would you put those doors and windows on there. That is a great spatial task. You also might want to just decorate one. So this is an example. I had my daughter help me with some decorations where she just did different patterns on it. And it might just be kind of an artistic thing for the child to create something to hold or to even just hang. So that's what we're going to do for the next couple of minutes is we're going to let you maybe try a new net. Maybe you want to do some art on the polyhedron that you just made, or maybe you want to try a little house. And there's a picture there of the house that Aileen made that even has a little light with the windows cut out. So have some fun playing with your polyhedra.
All right, we're going to give you a few minutes to do that, and we'll see you back here. We're going to also look at some different kinds of nets when we come back and have another exploration. So stay with us. All right, so welcome back. We hope you had some time to just decorate your cube and explore just the different shapes. I want to emphasize that in the discussions that you have children counting, especially if they're young. You know, you had started out with this array 4x4. How many squares did you use to cut out? And can you still see all those shapes of squares as it comes up to be a cube? I think that's one aspect of the decoration piece, that if you're decorating it when it's flat, you have to kind of gauge how it's going to look when it comes up to become a cube. And it helps children just, again, practice that spatial ability, because you can see how this shape that seems upright will later come back around and it's the back of it and upside down that shows as the front of the house. So that's kind of a way for children to kind of explore that spatial reasoning and that space that they're discovering and investigating around this net that turns into a cube. So we're going to set you up for kind of a problem solving way that you might use this activity. And Bev is going to take us through just the beginning so that you as a learner can engage a little bit in some of this problem solving. So Bev's going to take us through a different type of net around a cube.
Awesome. And Aileen, I'm going to get right to that, but I wanted to just show some examples. So this was one of the examples that we had given people if they wanted to try another net. And just so before we get to start problem solving on our own, because we're not going to show you where to put the strings on the next one, I just want to like show some possibilities. Like on this one, I kind of put holes in a line right here, but it still followed that principle that once you come to the inside, you need to go from the inside outside. So that's one of the important things that we want to be thinking about. And you see these diagonals as well. Diagonal is a really important word. I was teaching a kindergarten class today and we use that word. Like those really are in our world. I know we don't name them that, but the more as parents and as teachers, we have that opportunity to show them that, I think that becomes really powerful. And in the contrast, so like you see this net comes up and it almost becomes like this little cave. And then it does this flip over thing, which I probably need to tape it down. But I thought how, like, that was kind of like a shocking somersault at the end. Whereas this one, it kind of does that, but just the way that the string is moving, it kind of comes all the way over more towards the beginning, where this one you can almost see like two layers of it. This almost reminds me of like a sled that you were going down. So I just wanted to kind of highlight that before we completely send you off on your own. Those are just some things to be thinking about. So we are going to be folding another one, and the one that we're going to be making looks kind of like a stair. So we start with our square piece of paper. And remember, if you don't have a square piece of paper, that's okay. You use the edge here to fold it over, and then you draw that line to cut that piece off, okay? Because we want to start with a square. So now we have our square, and the first thing we're going to do is fold our paper in half. So once we fold it in half, we're going to open it up. And I got my other handy paper over here that helps us see. It has a line right here. We're going to take each side and fold them into that center line. So it almost looks like a book. I'm going to go through a little faster this time. So if I need to slow down, please let me know. Cardstock definitely works great as well. But when you're folding it and you're moving on these hinges, that becomes even more important. You really want to be able to push down on that. You could even give them a little book or something to help put all of those lines. All right, so remember, we're wanting to go both ways for each of these folds. And what we end up with are those four equal parts. Now with this, our lines were going up and down. Now we're going to turn it because we're going to do the exact same thing, just we're folding halfway along this side. So we fold it in half. We end up with 8 pieces now. Now that we have our 8 pieces, we fold into that center line and we make that book. But don't forget, we've got to fold them both ways. So I always flip it over. And then we're going to flip this one over. And again, that's so that as you're building that polyhedra, these are very flexible when they come together. So now we have our grid. We also call that an array. We're going to make, and I'll show you, what is like steps. So you can kind of put it anywhere, start anywhere, but what I'm going to do is I'm going to take these sticky notes and I'm going to say these are my first 2 steps. All right. So now there's my next 2 steps. And there's my 3rd steps. And then we don't need anyone along this top row. There we go. Okay, so now we cut it out. And again, I'm cutting out all the squares, cutting off all the squares that have a sticky note on them. Don't need that anymore. Cut each of these off. What I love about this net is it's a pretty surprising net for a kid to think that this is going to become a cube. So you might even just have the net out and let them kind of tinker around and see what it would come into as they're folding it. So here we have our net. Now we want to think about, how do we want this thing to come together so that it can form a cube? But we're not going to tell you where to put the holes. We're going to give you some more playtime. We can't give you too much because we were a little behind schedule today, but we want to give you some time to think about, where would you put the holes? How do you want this to come together? So we will give you just a few minutes, maybe 2 to 3 minutes, to kind of tinker around and just kind of explore how you want this net to become a polyhedron.
Yeah, and when you take some time just playing around with that and thinking about that, feel free to put your answers in the chat and share them with each other and share them with us. So we'll give you just a few minutes. All right, we know that wasn't a lot of time. We don't have probably enough time for you to completely try to problem solve. Remember that you might make holes at first in your first iteration that you try and then you don't end up using because that's your first iteration, just a way to try it and see what happens. And part of this also allows some predicting if it'll work or not. And I love that Bev has that out still, because I think what we could talk about is that we still have 6 squares that we're using. It's in a different arrangement. And a lot of questions you might ask for older students: is there other arrangements that come up as a cube? And is there other arrangements that don't come up as a cube? So those are some great things to think about.
Yeah, Aileen, I think about when I had to look and see which of these nets is not a cube and which one is a cube. And if I had known how to do something like this, it would have been so much more exploratory and playful. So it's definitely a fun way for kids to just think about that and then maybe start paying attention to sides and nets and edges. So the thing that I love about this, you'll notice that I've put the little squares already on where one option for making this to become a polyhedron. I love that they're along the diagonal. Like both of them are just along the diagonal, which, kind of goes with this whole stair notion. But it also made me think as I was putting it together is you can see the 3 as they come together. It's like they're all on the same point or vertex on the cube. Like that's where all of that string is going to go, which is kind of interesting. There's not, at least not one that I found yet, a net that does that. So I'm going to punch my holes so I can do some threading with you guys so we can have 2 cubes that we've made, 2 pull-up polyhedras. And again, it's a lot like a diagonal. All right, so we've got our holes. Now what we're going to do is we're going to keep following that pattern of, we're going to go from the outside in, then we're going to go from the inside out, then we're going to go from the outside in. So again, we started on the outside and we went inside. Now we go inside to outside. Now we go outside back to inside, and then you'll have a line across here. And we've gone from inside to outside. So now that we're outside, we start outside and we go inside, which is so interesting. I remember doing some sewing with my mother and having to remember, wait, which side am I on, the inside or the outside? All right, and we just stopped on the inside here, and now we go from the inside to the outside. And now, got to get some handy tape here to hold it down while we're gonna pull it up. And I always, when I tape it down, I tape it on at least 2 sides. Sometimes it helps to do 3. And we start pulling it. And this one, it's a little easier when you do one side first and then you pull the other side. So sometimes, you can experiment. You make your net come up the way you want. Maybe we'll try this side first, see what happens here. And then it's like we needed one more pull to close that door at the end. So very fun. My girls were helping me build houses, and we did try some other polyhedrons right here. So I love the idea of going and looking online, find some different nets and start seeing. You can see all my practice holes. So part of this, that's the engineering that we want to give that opportunity for kids.
Yeah, these are some great activities, the great way to just explore, and all the way up to adults in engineering classes. I mean, taking some of this and just exploring and seeing how you build things and how you use that functionality of pulling the string to create that 3-dimensional object. I had done my stair step, but in a totally different way. The strings are not connected, they're actually separate. And I noticed that I have mine flipped to the way that you had yours. So unlike the cross, if you flip that over, it looks exactly the same. If you flip the stairs over, it's facing the other way. And that might change the way you have, I don't know if that changes the way you have to pull the strings. It could be exactly the same, but it changes the way the orientation is. So lots of different ways you can explore with this activity.
Yeah. And that's really the engineering piece. And that's kind of why I wanted to highlight that at the beginning. You make that cube come together like you want it to. When I was having my daughter and she was playing around with some of her Lego figurines and we were pulling the different nets, I was surprised at how intrigued she was at which way she needed to pull, what string at what time. So she really kind of got into that problem solving. And then she was the one that helped me to kind of see which one we might want to do first and which one we might want to do second. So sometimes I think these kids are from another generation. They click and touch and they make things, they problem solve so much differently than I think my brain is hardwired. But this is just such a fun, hands on way for kids to be exploring those different dimensions while also thinking about simple tools like scissors and tape and string. I mean, what if we could do it with another shape? Can we make other kinds? Like, does this only work for a cube? Well, of course not. But where are those? So we actually have a video for you guys as well that just shows you another example. We chose a cube for this webinar because we needed to be able to use simple things from your home, and we knew that we could fold that together. But here you'll see another example.
Yeah, so here we have what we call a pyramid, a tetrahedron as well, but it uses equilateral triangles. So we iterated, or we have our square 6 times to make our cube. And if you take an equilateral triangle that's equal sides all the way around, you can make a tetrahedron. And there's other shapes you can actually make with that same shape. So definitely other ways to explore different shapes, different nets, and just have fun exploring.
Yeah. And I don't know if anyone wants to put in the chat, is there something maybe specific that you feel like would be a great thing to highlight with this activity, whether it's with a particular age of kids, maybe it's a math concept or a science concept? Go ahead and please just put it in the chat. That's one of the great things about this. Even as Aileen and I were making them, we thread them a little bit different. And so we really are trying to move away from thinking that there's just one way to do something. We want to give kids this open-ended space to really be thinking for themselves.
Thank you, Bev, so much for coming to us with this activity. We don't have time to talk about all the questions, but I think we talked a little bit about the questions you could ask your child as they engage, like, what shapes are they seeing? How would they describe just that transformation from a flat shape to a larger shape? How accurate they are in following instructions, just a side-by-side play and engagement that can happen together with a caregiver and a child, but also teachers can lead parents in being able to do something like this, maybe virtually, where there's facilitation and support.
Yeah, so in the chat, Lisa mentioned thinking about how many holes you have to punch for the different nets, which I think that's a really interesting problem because if you look, well, we don't really have a lot of time, but if you looked on my nets, you would notice that it's not the same because sometimes you need to pull something when I'll hold it up. The triangle that had, that was like a capital T, I had to put 2 holes in order to kind of pull it down right here because it kept flopping over and it wouldn't stay upright. So that is such a fun question to think about. And is there a pattern that emerges? I mean, we don't know. So hopefully today we've sparked your curiosity and there's something for you to explore with children or even for yourself, because I don't know about you, but I've been quite fascinated and had to redirect myself sometimes because I could have spent a lot more time finding these different nets and thinking about how to pull these together. So I was definitely drawn into some of that engineering as well. So I love it. People are talking in the chat, using this for story elements. Each element is listed on one of the squares. What a great connection to language arts. Which shapes can you use to create a polyhedral? Hexagons, pentagons. like just being able to think about that. And maybe they even take, what if they even took like a pattern block or something really simple and started tracing it? And although we had it as a net that you actually was all connected, you can remember, take some good old fashioned tape and you could just cut them all out and tape them together. That might be a really fun exploration as well.
There's so many different things. And as you're doing this, we encourage you if you want to put some pictures on social media and tag us and show us how you made this activity your own and integrated maybe with literacy or other playful ideas, please share those. We'd love to share them with others. So we just want to remind you that on our website, oh yeah, here's the tags that you can use to mention us in your post so we can follow you and see what and how people are using some of these activities in their own way. We also want to mention that on our website, you'll find resources around this activity. There's a one pager that has the questions, things to watch for, also connected to a instructional video that you can use and watch later if you'd like to review just the steps or share it with others, maybe use it in a PL with other teachers. And in our next Hands Online webinar, we'll be exploring bubbles and doing some activities around bubbles. Weather is getting a little bit warmer for some of us, and kids love engaging outside. So how can we explore STEAM around bubbles? And that will be our next subject on our bubbles, on our hands-on webinar. And we also want to talk about a play shop that'll be coming up in the next few months. We'll explore some of these other pull-up polyhedras and some other paper activities. So if you'd like to sign up for that, please continue to keep connected to our website where you'll see a registration link so you can join us on one of those longer sessions. We have a little bit more time to explore and make together. Thank you again, Beverly, for bringing us this very fun activity. Thank you everyone for joining us today. Stay connected with us on our website, and we invite you to always join us in these spaces where we can make and learn together. Have a great afternoon.
Bye, everyone.